Okay, here we have the coral, which is in the shape of a rectangle with a semicircle, and the diameter of the semicircle is the side of the rectangle as shown in this diagram. So this x represents the diameter of the circle as well as the side of the rectangle. And we are told that to enclose this coral, 201 feet of fencing is required. And in this case, we have to determine the maximum area, and we have to determine the corresponding dimensions, which gives the maximum area. That is, we have to determine the side length x as plus y, which gives the maximum area of this coral. So let's see how to determine this. So it basically involves about three steps. The first step is to write the fencing equation. We will write the fencing equation, and then in the second step, we have to write the area equation for the coral. And in the third step, we'll use calculus to maximize the area. That is, at what point of x or y the area is maximum, and using that we can determine the other side length. So first we'll do the first step, that is we have to write the fencing equation. Since we are given that 201 feet is the maximum fencing, let's set up the fencing equation now. So as you can see from this diagram, this side length is x and this side length is y. So the fencing involves we have to consider this x and then plus y, and so basically we have 2y, so we can put this as 2y. We have two side lengths whose dimension is y, so I'm going to put x plus 2y. So this is the fencing which is required to fence along the rectangle sides of the rectangle. And now we have to fence along the semicircle. We know that if we consider a circle, the perimeter or the circumference of the circle is 2 pi times radius. However, if it is for a semicircle, we have to divide this by 2, so which gives pi r. So the fencing which is required for a semicircle, if we do not consider this, as far as this coral is considered, we are not considering this side length when we consider the semicircle. So it's basically only pi times and the radius. And since the side length or the diameter of the semicircle is x, we say that the radius of the semicircle is x by 2. And we will utilize this. This is the fencing which is required for the semicircle. So therefore the fencing of the semicircle is pi times of x by 2. And this gives pi x by 2. We will add this with our fencing equation, that is pi x by 2, and this equals the total fencing which is required to enclose this coral, which is 201. So we have set up this equation, that is x plus 2y plus pi x by 2, this equals 201. From this I am going to solve for y so that I can substitute when I find the area equation. So first let me solve for 2y, and this equals 201 minus x minus pi x by 2. Now I have to divide both sides by 2 so that I solve for y. So therefore y equals 201 divided by 2 minus of x by 2 minus pi x divided by 2 and then multiplied by 1 by 2. So this equals pi by 4. I can multiply this 2 in the denominator, and I can simply write this as pi x by 4. We can write this in a simplified form. So let's do that. So we get y equals 201 divided by 2 is 100.5, and we can factor x by 2 from these two terms. So I'm going to factor minus x by 2, and when I do that I get 1 plus pi by 2. We can double check this. So when we multiply this minus x by 2 times 1, we get minus x by 2, and minus x by 2 times pi by 2 is minus pi x by 4, which we have it here. So this factorization is correct. So this is the form that we will utilize for y. We are going to utilize this form of y, that is 100.5 minus x by 2 times 1 plus pi by 2. Okay, so now we will do the second step, that is we are going to write the area equation. So we have to find the area of this coral. This area of this coral, and this involves area of the rectangle plus area of the semicircle. We know that the area of the rectangle is length times width. So here we can consider this x as length or y as width. So therefore it is xy plus area of the semicircle. We know that area of circle is pi times radius square, and area of semicircle we have to divide this by 2. So it's basically pi times radius square by 2. And we already know that radius of the semicircle is x by 2, which we will substitute here and replace the radius. So therefore this becomes xy plus we can write down this as pi by 2. R is x by 2. I'm replacing R as x by 2 quantity squared. So this gives x times y plus pi by 2 times x by 2 quantity square is x squared by 4. And in fact we can simplify this. So this becomes pi x squared by 8. So I can just replace this as pi x squared by 8. We will also replace y now, since we have to write down this area in the one variable. We cannot work with the two variables. So we have to replace y in terms of the expression for y as we have determined after step 1. So let's do that. And when we do that, we can consider this as a function of x. So I'm replacing a by a of x. So this becomes x times of, let me replace y as we have found in the first step. That is 100.5 minus x by 2 times 1 plus pi by 2. And then we have this pi x squared by 8. So I'm writing this pi x squared by 8. Now let's get this simplified. So we have a of x. I'm going to distribute this x into the terms inside the brackets. So x times of 100.5 is 100.5x minus x times of x by 2 is x squared by 2 times we have this factor 1 plus pi by 2. We also have the last term, that is pi x squared by 8. We can also simplify this further by factoring out x squared from these two terms. So let me do that. So this becomes 100.5, 100.5x plus I'm factoring the x squared. So when I factor the x squared, first let me consider this term. I have pi by 8, so I put pi by 8. Now I'm factoring only x squared from this term, that is the first term will be minus 1 by 2 times 1 if you do the distribution. So I have to put this minus 1 by 2. And the next term will be minus 1 by 2 times pi by 2, which is minus pi by 4. So these are the factors that we get after we factor the x square. Now we will simplify this. So a of x, and this equals 100.5x plus x squared by 2. We can combine these two terms and simplify this. So let me do it here. This is pi by 8 minus pi by 4. To make common denominator, I multiplied the second term by 2 and divide by 2. So therefore this becomes pi by 8 minus 2 pi by 8. So therefore we can now add the numerators. Pi minus 2 pi is negative pi by 8. So when we combine these two terms, when you simplify this as a single fraction, we get negative pi by 8, and we already have negative 1 by 2. So once again, we can also simplify this by factoring out the negative. So therefore, I can write down this area function, and this equals 100.5x minus, I'm just factoring out only the negative. So this will become negative x squared by 2 times of 1 by 2 plus pi by 8. I just wrote this in a different order. It doesn't matter. And so this completes our step 2. That is, we have written the area equation of the coral. We will now do the third step. That is, we have to find the dimensions of the coral such that the area is maximized. So for this, we are going to use the calculus first and second derivative methods to see that at what point of x the area is maximized. So first, let me consider the area equation, that is a of x, and this equals 100.5x minus x squared by 2 times 1 by 2 plus pi by 8. To find the maximum area, we have to set up a prime of x equal to 0. A prime of x is the first derivative of the area function. That is, when we use the calculus first derivative, the function is always either maximum or minimum at the point when a prime of x equals 0. So that is why we have to set up this equation. So let's determine the a prime of x. That is, we have to find the derivative of the a of x function. So I write down a of a prime of x by finding the derivative of this area function. So here 100.5x, its derivative is 100.5, and then we have negative x squared by 2 times 1 by 2 plus pi by 2 pi by 8. So if we find this derivative, we can write down this as negative 1 by 2 times the derivative of x squared is 2x, and then times 1 by 2 plus pi by 8. Okay, I see that there is a correction required here. This is actually negative x squared. It's not negative x squared by 2. So this has to be negative x squared only. And so when we find this derivative, it will just be negative 2x, and we will not have this negative 1 by 2. So it's basically this expression. We just remove this and write it once again. So it's negative 2x times 1 by 2 plus pi by 8. Now let's set up this a prime of x equals 0. So we put the first derivative equals 0, and when we do that, we get 0 equals 100.5 minus 2x times 1 by 2 plus pi by 8. We solve for x from this equation. So this implies we can solve for x. So we get 2x times of 1 by 2 plus pi by 8, and this equals 100.5. So therefore, we can solve for x by dividing both sides by the factor uh, that is we have it as a product of uh, terms in the left side. So therefore, we will get 100.5 divided by 2 times of 1 by 2 plus pi by 8. Now we can find the value using the calculator. We plug this expression into the calculator, and when we do that, we approximately get x is 56.29. So this has to be in feet. We will now double check if this gives the maximum area. For this, we have to find the second derivative of the area function. So we have to find a prime of double x, and we have to find or substitute this value of x into the second derivative at the critical point. This is basically the critical point. So when it is less than 0, we see that the area is maximum, and when it is greater than 0, we see that area is minimum. We will now check that. So I'm going to first find the second derivative of the area function. For this, I'm going to use this expression, that is a prime of x. So let me first copy that. We have a prime of x, and this equals 100.5 minus 2x times 1 by 2 plus pi by 8. So we have 1 by 2 plus pi by 8. Now we'll find its second derivative by differentiating both sides with respect to x. So we get a double prime of x, and this equals the constant will become 0, and we will get the derivative of 2x, negative 2x is negative 2, and then derivative of x is 1, so it's just 1, and these are all constants, so we put the constant as it is. So it is basically negative 2 times of 1 by 2 plus pi by 8. This is definitely less than 0 because we have a factor negative 2, and the sum of two positive quantities is going to be positive. So negative quantity times positive quantity, this is always going to be negative quantity or less than 0. So it satisfies this condition, that is the second derivative function at the critical point is less than 0, which means this at this critical point the area is maximum. So we have verified this area is maximum at this point, that is at x equals approximately 56.29 feet. Now we can find the corresponding y using the equation that we found in step 1. So I'm going to use this equation, that is y equals 100.5 minus x by 2. I write down here 100.5 minus x by 2 times 1 plus pi by 2. So we just substitute the value of x, that is 56.29. X is approximately 56.29. We have to plug it into this y expression. We will do that. So it gives 100.5 minus 56.29 divided by 2 times 1 plus pi by 2. Once again, we plug this expression into the calculator. All these are some numbers or some constant. So we will definitely get some numerical value. So y is approximately 28.14 feet. So we found the values of x and y. These are the dimensions of the coral, which gives the maximum area. So we see that x approximately 56.29 feet, and y is approximately 28.14 feet. So these are the dimensions of the coral which gives the maximum area.